Hi everyone, I am going to run through a quick couple of examples on how to graph tangent curves. We are not going to be graphing cotangent curves this year, so if you run across, when you run across those in your homework assignment, just go ahead and skip over the cotangent graphing problems. So first of all, I am going to write the equation for the generic tangent equation. So that would normally be y equals a times the tangent of bx minus c plus d. And this year for our class, just for our purposes, we are not going to worry about the d or the a value. The d is the midline, so it's that vertical shift still. A is your vertical stretch. We're figuring if you can do that with sine and cosine, that you're going to be able to do it with tangent. The thing you are going to have to worry about with A just a little bit is that it does have a sign change. So you could have a positive or a negative A value, and that'll control the end behavior of your graph. So let's go ahead and jump into this. Typically, we would start with either the midline or the amplitude, but like I said, those are not changing for tangent curves. So I would take the inside of the tangent here and set that equal to 0 in order to find our phase shift. So the phase shift is always where the parent graph would normally hit 0, where it has moved to. So in this particular case, sorry, I wrote a B, I didn't mean to. So in this particular case, we're going to take our 2x minus 3 pi and set that equal to 0 to get x equals 3 pi over 2 as our phase shift. And so now we need to know the period. And to find the period, instead of taking 2 pi and dividing by b, which is what we did for sine and cosine, tangent only requires half of the circle instead of the full circle to get a wave. So we're going to take a length of pi, which is half of a circle, and divide that by our b value, which is the coefficient of the x. So in this case, in this particular problem, our period will be pi over 2. So now we're going to go ahead and find our key distance. Now to do that, we're going to follow the same method that we used for sine and cosine, which is taking the period of pi over 2, and we're going to multiply that by 1/4. So the pi over 2 is just what the period happens to be for this particular problem, but the 1/4 is always going to be the case for the key distance. So it's like you're cutting that circle into 4 quadrants. So in this case, our key distance is going to be pi over 8, and then that is going to let us find our locations that we're going to put on our x curve, or sorry, our x-axis. The strange thing about a tangent shape is that you don't start at the beginning, you actually start in the middle of a tangent curve. So if you looked at the web page where we translated the circle into the waves or the curves, tangent actually started in the middle. So we're going to put our phase shift in the middle of our locations. So I'm going to write 3 pi over 2 in the middle there. And then I'm going to add to that pi over 8. And I'm going to add to that pi over 8 for my key distance. So that's going to take me, I'm going to do a quick sketch here. So our tangent curve did something like this for our parent graph. So it's going to take us from our intercept through to 90 degrees, what would typically be 90 degrees. So that's our key distance, and that's our key distance. But then we're also going to move backward our key distance. So we're going to also subtract, which my crazy brain makes me add a negative in order to subtract. And that's going to let me find the locations on the x-axis. So I'm going to erase the yellow tangent curve out there. Well, eventually. And I will then be able to go ahead and create my new graph. Okay, so now I am going to go ahead and write my actual locations. I do have to get a common denominator here. So that's going to turn out to be a 12 pi over 8 and a 13 pi over 8 and a 14 pi over 8 and then 11 pi over 8 and 10 pi over 8. So those are what I'm going to drop onto my x-axis, and it doesn't matter if you start at the left and go to the right, or start at the right, go to the left, or start in the center and work your way out. Just make sure you are reducing as you go. So the 10 pi over 8 turns into 5 pi over 4, 11 pi over 8, 3 pi over 2, 13 pi over 8, and then 7 pi over 4. And so now I'm going to drop in my y-axis. Once I've got my x-axis labeled, I'm going to put that over on the left here because that's where it would go according to the values. We only need to go up 1 and down 1 from our x-axis. If we had an a value, that's where the a value would end up going. But like I said before, we're only going to have a positive 1 and a negative 1 for our purposes this year. So now we just need to know the pattern. So for sine and cosine, that was, for sine it was mid, high, mid, low, mid. For cosine it's high, mid, low, mid, high. For tangent, the pattern is A, P, Z, P, A. And that means asymptote. We've got an asymptote, we've got a point, a 0, another point, and then an asymptote. So the easiest things to start with are the asymptotes. So our outside locations, those are just going to be vertical asymptotes. And then it's actually easiest next to go to our middle location, which is a 0. So if we had a vertical shift, a d value, that point would be on the height of a d value. And then the points. So that means we're either going to have up on the left point, down on the right, and then we would have an end behavior that kind of does this, or vice versa. And the way we tell is based on the a value. So if our a value is positive, then the right end behavior of the graph is going to point up. If our a value is negative, the right-hand value of the graph is going to point down. So in this case, our right point is going to be up at positive 1, and our left point is going to be down at negative 1. You connect those in pretty much a straight line, and then you slide up the curve, or sorry, up the asymptote and down the asymptote in order to create a gentle curve on the ends. One last thing that you need to be able to do, and that is write the general form of the equations of the asymptotes. Oof, not sure what letter I was writing there. So the general equation of the asymptotes is going to be, you're going to pick one of the asymptotes. It does not matter which one. I'm just going to pick the first one here, the 5 pi over 4. And you add to that the distance to the next asymptote, but that distance is the period. So in this case, that is pi over 2. So we'd say we start at one asymptote, we're adding the distance to the next one, but we can do that as many times as we would like, so that n value, so that we can reach any asymptote anywhere along the tangent curve. Let me know when you've got questions. I'm going to pause this, go ahead and write out the answer to problem number 2 here, and then you can check your answer when you hit play again. Check your phase shift if you would like. All right, there's your answer to the second equation, or sorry, the second tangent curve. There's your graph. One more thing, I'm going to write the equation of the asymptotes, which I have not yet done, but I'm going to scoot the whole graph up, so don't let that scare you when it jumps. All right, so again, that is going to be one of your asymptotes for the 9 pi over 2 plus 3 pi, which is the period, times n.